Hello students, today we will discuss unit 1 antenna and radiation parameters. Unit 1 we will learn about different antenna radiation parameters. Those parameters are radiation pattern, radiation intensity, gain, directivity, effective aperture, radiation resistance, bandwidth, beam efficiency, matching antenna noise temperature, radiation from oscillating dipole. So up to noise temperatures, these are the parameters. And remaining, we will understand how these parameters are used to characterize the basic antennas. So radiation from oscillating dipole, half a dipole and quarter wave monopole antenna. So for this antennas, we will see this radiation parameters. First, we will see what is a radiation pattern. And in this course, we are going to study antenna and its wave propagation. Before that, we should know what is the antenna. Here you can see that in our life, each and every one we used to carry antenna with us. That means every one we are having one antenna with us. For example, we are having a mobile phone. So in mobile phone, we have one antenna. Because of that antenna only, we are receiving and transmitting signals. So like that, in many places, we can notice the application of antenna. And many times, we can see the tallest mast or tower. So where we have a different shapes, that is different shapes of antenna, like a disc or a vertical antennas. Okay, that is a disc like antenna is a kind of a parabolic reflector antennas. Also, we have in our room nowadays we are receiving satellite channels. That is a TV channels through satellite. That is possible by DTH. So direct home that we are having a parabolic reflectors only. So like that we have many applications. Okay. So we will see in forthcoming unit 2, 3, 4 on this different type of antennas, how we are using these antennas in our real life. For that, we need to understand what are the basics of antennas. Let's say. So we can say that antennas are one transducer, which is converts electrical signals into electromagnetic waves and vice versa. Because suppose I'm talking here, suppose I'm using one transmitter. So transmitter is the electronic circuitry with the antenna. That is simply we can say transmitter. So if I talk here, my voice signal is converted, that is picked up by mic. Okay, the mic which converts voice into a physical signal into electrical signals. So this electrical signal to be transmitted into the free space. Then only it is possible to receive in other sides. So we have to convert this electric into electromagnetic waves format. So our signals are transmitted, that is being propagated in a medium in electromagnetic waveform only. So this antenna does a job that converts electrical signals into electromagnetic wave. If you are using antenna as a transmitting purpose. So it is the case of signal receptions. We know that we are our India, in ISRO, we are launching many satellites for space explorations. So how it is possible to receive signals from this deep space is we are having that much size of antenna to receive the interference deep space signals. That is a receiving antenna. So there also we have a electromagnetic waves received, which is converted into electrical format. That's why I say it is vice versa. Actually, we have different types of antennas. So we have given some types because we can categorize antennas based on different parameters. For examples, I can categorize antennas based on operating frequencies. Maybe mid-range, low frequency operations, very high frequency operations. Based on that, we can classify the antennas. Second, polarization. So the antenna may use the vertical polarization or horizontal polarizations or elliptical polarizations based on that. And next, directionality. That is a directivity based also we can classify antennas. So there is more parameters like this to classify antennas. Here we will see some antennas. First one, dipole antennas. So dipole antennas, it is a very mostly used antennas. For example, we can see while traveling, so traffic policemen, they are using walkie-talkie. So this walkie-talkie is made of a dipole antennas. So they have basically two types. One is the off-air dipole antenna. Second is a quarter wave monopole antennas. Second, patch antennas. So patch antennas find applications mostly in wireless communications like Wi-Fi and Bluetooth. Why it is so called as a patches? Their shape is a flat, they're very thin in size. That's why we find application in Wi-Fi and Bluetooth. That is simply wireless applications. The third one is Yagi-Uda antenna. So actually, it's not an antenna, it is an antenna array. So later we will discuss what is the antenna array. So Yagi-Uda antenna is, suppose a decade or 2 decades back, if we go, or if you encounter with your parents, you can get an idea about application of a Yagi-Uda antenna. Those days, Yagi-Uda antenna used for receiving television signals. So in each and every home, they had a Yagi-Uda antenna, and you have to tune Yagi-Uda antenna by properly adjusting its directions toward the television signal relay station or a TV station. Okay, nowadays we don't use the Yagi-Uda antenna for receiving television signals because this Yagi-Uda antenna for receiving television signals replaced by DTH. That is, we are using parabolic, that is a dish antennas. Okay. So in this Yagi-Uda antenna, we have a basic 3 elements. One is the driven element, which is the active element. We are feeding our input. Remaining 4 passive element, that is parasitic elements. One is the reflector, second is the directors. We will see this elaborately, detailedly in unit 2. The last one is the parabolic antennas. One of the type in this parabolic antenna is, so that is a DTH, dish antennas. You can notice that, you can see that in DTH, that is dish antenna, we have 2 parts. So one is one circular disc. In front of that, there we have one more antenna. Okay, so here a parabolic antenna is secondary antenna. The antenna which is used in front of that dish. See, So that is the primary. Okay, so we will see that. So here I have given some pictures. So here we have one dipole antenna which is fixed on a car to receive the FM signals. In those days, 2-3 decades back, we have transistors. This is a stretchable conducting medium, which is the dipole antenna to receive the television, sorry, radio signals. And this one we know very well, familiar with this. That is the walkie-talkie. This is the monopole antenna, that is a dipole antenna. Now we see some applications of antenna. First one is communication systems. To receive or transmit signals, we need an antenna. Okay. So mobile communications and radar systems, or the satellite communications, radio and television broadcasting, everywhere. Without antenna, it is not possible. Second, scientific applications. So space explorations, radio astronomy. Let me tell you one interesting. If you have a habit to watch National Geography or Discovery Channel, you can find that those persons, that is a scientist, wildlife researchers, they used to carry one antenna to detect the animal movement. For example, if they keep one RFID like one RF tag into animal body, they can receive the RF signal from the animal. So that if we want to detect animal movement, so we need to carry one antenna which will receive RF signal from that RF tag or a chip which is etched into the animal body, so that we can find where is actual direction or location of the animal from our antenna by using the antenna. For example, loop antennas or Yagud antennas. We used to say that these two antennas are directional finding antennas. So loop antennas, Yagud antennas are having high directional, that is so we can pick up the RF signal from the animal body. So we can identify what is the direction, in which direction animal is moving. Now let's see that some basic parameters to understand an antenna. So radiation pattern, radiation intensity, beam width, radiation power density, directivity, antenna efficiency and gain, polarization, reciprocity, antenna aperture, and more. There are many parameters. We see some very important parameters.